Hello and welcome back to day 3 of trig exact values. We're going to continue to look at those special triangles, but we're going to go ahead and put those on something called the unit circle, or create the unit circle. And in addition, we'll do some basic math, adding and squaring of these trig ratios. You recall, given just a limited amount of information, we can create these special triangles. One's called a 45-45-90, the other's a 30-60-90. I did that work yesterday. And what we're going to want to do is create the similar triangles that have the same hypotenuse length. And we can do that by dividing the 30, 60, 90 by 2 and the 45, 45, 90 by square root of 2. And we get a hypotenuse of 1. Of course, this guy needs to be rationalized. So square root of 2 over 2 will be the ratios we use. The nice thing here is when we find opposite and adjacent over hypotenuse, we're dividing by 1, so it'll just be the values that we've found here for our sine and cosine. So the cosine and sine are pretty straightforward. The tangent takes a little bit of work. We have to divide fractions, and the tangent's the opposite over hypotenuse or sine over cosine. So what we would do for the 30, 60, 90, divide opposite, or sine divided by square root of 3 over 2, which is same as multiplying by the reciprocal. And that gives us a 1 over root 3, or when we rationalize, root 3 over 3. Same thing for the 45. In this case, we've got a root 2 over 2 divided by root 2 over 2. Well, those are the same lengths, and that reduces to 1. And the tangent of 60 will be basically the reciprocal of our tangent of 30. We'll do the work. Root 3 over 2 divided by 1/2 means we multiply by the reciprocal, and we get square root of 3. These are going to be 3 more values we're going to want to get familiar with. Remember the ratios from yesterday's lesson and the ones I showed right at the beginning of this lesson. They're the same triangles. We just have created what's called similar triangles by doing some kind of a ratio. What's done there is given us a hypotenuse that's the same for both special triangles. And we're going to apply this to something on the coordinate axes, which becomes the unit circle. So if we take these values and place them out here on the coordinate axes, you'll see that all these values for cosine, when we divide by 1, we just get these values that are listed here. Those become our x-coordinates. Likewise, these values on the right, the vertical, become our y-coordinates, and they're just the sine values. So we don't even have to do a ratio anymore. We know those coordinates. What does this look like then on the unit circle if we go around 360 degrees? Well, if we want to look at cosine, we know the values that are angles anywhere from 0 to 90 or 270 to 360. Those are going to be positive values. And on the left side of the y-axis, those will be negatives. So if we look through here, we notice the 115, the 210, the 225, and the 135, and then the 120 and 240. Those are going to be negative values. Same ratio, just negative values. If we take a look at sine, the positive and negative is separated by the x-axis. Take a moment here, hit pause, and see if you can determine the negative values. Okay, those are going to be values below the x-axis. So that's all these. Notice that a point 1 unit from the origin at a given angle of a degrees, and we can just make up some angle that's between 0 and 360, will basically provide what was shown earlier, an x-coordinate that's the cosine, a y-coordinate that's the sine of that angle, and the value for tangent is simply going to be opposite over adjacent, or y over x, or sine of a over cosine of a. So let's practice. Take a moment, see if you can get these values. Okay. If we look at the angle 315 degrees, we have this reference of 45. That gives us our root 2 over 2 and negative root 2 over 2. The cosine is the x part, the horizontal. We look at tangent. of 225. That's down here. That's a 45, 45 as well, only we have values that are negative. Tangent's going to be opposite over adjacent. They're the same. Our value would be 1. Same spot, if we look at cosecant, remember that cosecant is the reciprocal of sine. So if sine would be the negative root 2 over 2, this will be negative 2 over root 2. We multiply by root 2 to rationalize. This becomes a 2 on the bottom and 2 on the top. We get negative root 2 here. And for cotangent of 150, that's going to be this 30-degree reference angle, a negative root 3 over 2 for cosine, and a positive 1/2 for sine. Cotangent's the reciprocal or adjacent over hypotenuse for tangent. So negative root 3 over 2 times the reciprocal of 2 over 1. 2's cancel, you get negative root 3. All right. I've left out the axes on purpose because they get a little bit tricky. We want to look at a triangle that gets really, really small. It essentially has a horizontal position of 0 at 90 and down at the 270. And then has an adjacent, or an opposite, I'm sorry, of 1. Likewise, if we were to look at sine, it would be a 0 out here and a 1 for the adjacent. So let's see what that does. Got a lot of values we can look at here. I'm just going to do these 5. Why don't you take a moment and see if you can get these values using the coordinate axes. Okay. Well, if we look at the cosine of 90, we essentially have an opposite of 1 and an adjacent of 0. We're looking for cosine. That's the adjacent. That would be a 0. For sine of 180, we'd come out here. Again, this side would be getting smaller and smaller down to 0. The adjacent is a negative 1 in this case. We're asking for sine, so it's a 0. If we continue practicing some of these values, let's look at some that are not on the axes. Cosecant of 135, that's going to be out here. Reference angle of 45, that's got a root 2 over 2 and a negative root 2 over 2. Cosecant's 1 over sine, and that would be 2 over root 2, and that would be a positive square root of 2. If we looked at tangent of 210, that's down here. Tangent's going to be a negative root 3 over 2 and a negative 1/2. Opposite would be the negative 1/2 divided by negative root 3 over 2 or multiplied by its reciprocal. Negative times negative will be a positive. We get a 1 over root 3 or a root 3 over 3. And that's a positive there. Finally, we can look at cotangent of negative 45. All we do there is spin around. It's essentially a 315-degree angle, but we've got negative. It's negative root 2 over 2 for the opposite, root 2 over 2 for the adjacent. Cotangent's going to be adjacent over opposite. They got the same value, but there's a negative there, so you would get a negative 1. That pretty much concludes the unit circle, and then we're just going to do some basic math with some of these trig functions. Go ahead and take a moment, see if you can recall adding and subtracting. Remember, you need a common denominator. So go ahead and hit pause. Okay. The advantage in this first one is we do have our common denominator. We simply add the numerators and we get 4 over 7. For the second fraction on the right here, we can multiply the left fraction by 5 over 5, the right side by 9 over 9. That's just multiplying by 1, and that doesn't change the ratio. Gives us a common denominator of 45. 25 plus 18 is 43 over 45. Likewise down here, we get our common denominator of 33. 6 plus 11 is 17. All right, let's apply this to some of these messier values here. The sine of 150, I tend to draw my angles here. That's a positive 1/2. The cosine is a negative root 3 over 2. So if we had to add these two values, negative root 3 over 2 plus 1/2, they have a common denominator, we would just get a 1 minus root 3 all over 2. To square these values, 1/2 squared is 1/4. Negative root 3 over 2 squared is going to be a positive, 3/4. Add these together, we would get 1/4 plus 3/4 equals 1. In this next slide, why don't you try to do the work, see what you come up with, and then we'll go through the answer. You can hit pause. Okay. Getting some trig values here. The sine of 135 is a root 2 over 2. And the cosine of 180, that's way out here, it's a 0. That's a negative 1. To add negative 1 plus root 2 over 2, we need a common denominator. Multiply top and bottom by 2. We would get negative 2 over 2 plus root 2 over 2. So negative 2 plus square root of 2 all over 2. Coming down here, to square these values, square root of 2 over 2 squared is going to equal 2/4 or 1/2. Cosine of 180 was negative 1. When we square it, we just get a positive 1. And to add these values, we add 1/2 plus, let's call it 2 over 2, giving us 3/2. Okay, a lot of old math to review. Go ahead and try these problems on your own, and we'll discuss the lesson in class.